Good morning children. Today's experiment is salt analysis. Analysis of cations and anion present in simple salt. You are provided with white crystalline colorless salt. That is, you will have to detect the presence of cations and anions. What are the cations and anions present in the simple salt? So first one is the systematic analysis of anion. First one is Testophore Carbonate. Little of the salt is taken in a test tube and are dilute hydrochloric acid. Dilute HCl is added to the salt that is taken in a test tube. Then observe the change. No brisk effervescence. You can see no brisk effervescence is observed. So absence of carbonate. The test is negative. So we will have to repeat the experiment for the next anion, that is acetate. Take a watch glass and add little of the salt to it, and that is rubbed with dilute sulfuric acid. Little of the dilute H2SO4 is added to it, then rub the salt. Note down the smell. Vinegar like smell is there. Just note it down the smell. There is no smell of vinegar. So absence of acetate. The test is negative. Test for chloride. Little of the salt is taken in a dry test tube and are concentrated H2SO4. 2 or 3 drops of concentrated H2SO4 is added. Then heat the test tube. Then observe if there is evolution of colorless, odorless gas is there. Just observe. So there is no evolution of colorless, odorless gas. So chloride is absent. So now you have to add paper bowl to the boiling solution for testing nitrate. Just add paper bowl, then heat the contents. Just heat the contents. Then you can observe brownish color gas is evolved. Reddish brown vapors evolved. So test for nitrate, that is positive test presence of nitrate. We systematically analyze the presence of nitrate. Then we have to confirm the presence of nitrate. Conformity test for nitrate, brown root test. For that, take little of the salt is taken in a dry test tube. Then you have to make a solution of this. Make a solution of the salt. Then kept aside. Then you have to prepare ferrous sulfate, freshly prepared ferrous sulfate solution for this brown root test. For that, you have to take ferrous sulfate in another test tube. Ferrous sulfate crystal. The solid ferrous sulfate you have to take in a dry test tube. Little of the ferrous sulfate is taken in a test tube. Then add some water. Then pour the contents first. Pour the water. Just pour the water. Then again add water. Shake it well. Shake it well to dissolve the contents. Then you will get the freshly prepared ferrous sulfate solution. Then take the salt solution that you have already prepared. Equal volumes of the solutions you prepared. Then just mix it well. Mix these two solutions. Mix these two solutions. Then shake it well. Then add concentrated sulfuric acid along the sides of the test tube. Concentrated sulfuric acid are along the sides of the test tube. Observe the change. A brown ring will be formed between the junctions of these two liquids. At the junction of the two liquids, the brown ring is obtained. So the presence of nitrate is confirmed. So we analyze the presence of anion, that is nitrate is present in the salt, and we confirm the presence of nitrate by brown ring test. Systematic test for the analysis of cation present in the salt. So before doing the experiment, you have to prepare the salt solution in a boiling tube and kept aside. Prepare salt solution in a boiling tube and kept aside. Here in this experiment, we will have to analyze group wise. So first group 0, we have to analyze group 0, then group 1, group 2, group 3, group 4, group 5 and group 6. In group 0, we are analyzing ammonia. Then group 1, lead. Group 2, we are not doing the experiment for group 2. Then group 3, we analyze the presence of aluminium. Then group 4, we analyze the presence of zinc. Then group 5, barium. Then group 6, magnesium. Okay, first is the group analysis, group 0 analysis. For that, a little of the salt solution is taken in a test tube and add sodium carbonate to the test tube. Sodium carbonate is added to the test tube and just observe the change. Here the precipitate is formed. So this indicates that absence of group 0, that is ammonia is absent. Ammonia absent. So next we have to analyze the group 1. For that, take a little of the salt solution in a test tube and add dilute hydrochloric acid to it. The group reagent we are using here is dilute hydrochloric acid. Add dilute hydrochloric acid to the salt solution taken in a test tube and observe the change. Yes, there is no precipitate or no residues formed. So absence of group 1, that is lead, is absent. We are not doing the test for group 2. So next is the test for group 3. That is, take the test tube, add some salt to it, salt solution. Then add solid ammonium chloride. Solid ammonium chloride. Using spatula, you have to add some ammonium chloride to the test tube, to the salt solution, and just shake it well to make a saturated solution. Just shake it well. Solid ammonium chloride. Shake it well to make a saturated solution. Now the next group reagent in group 3, that is ammonium hydroxide. Excess of ammonium hydroxide solution is added for analyzing the group 3. That is the presence of aluminium that we want to check. Okay, ammonium hydroxide solution is added. Now just observe the change. There is no residues formed. So absence of group 3, that is aluminium cation, is absent. Now we want to test for the group 4 analysis. For the group 4 analysis, the group reagent that we are using is ammonium salt solution and ammonium chloride, ammonium hydroxide. So to the salt solution, we can add H2S, that is hydrogen sulfide gases passed through the solution. That is the group 4 analysis. We want to check the presence of group 4 cation, that is the zinc. Just add H2S to the solution. There is no white residues formed, no residues formed. So the group 4 is also absent. Zinc is not present. So we want to analyze the next group 5. For that, salt solution is taken in a test tube. That is, take the salt solution in a test tube and again add solid ammonium chloride. Solid ammonium chloride. Make the solution saturated. Just check it well. We are analyzing group 5. The group 5 reagents are ammonium chloride. Next, excess of ammonium hydroxide. We are adding excess of ammonium hydroxide. Next reagent is ammonium carbonate. Ammonium carbonate is also added. Now just observe the change. There is no residues formed. So group 5 is also absent. The group reagent that we use here, ammonium chloride, solid ammonium chloride, excess of ammonium hydroxide, then ammonium carbonate. These are the group reagents. We analyzed group 5. The group 5 that contains this barium. So the absence of group 5. Next is the analysis of group 6. So the group reagents. First of all, we will have to take the salt to solution in a test tube. Take salt to solution in a test tube and add solid ammonium chloride. Solid ammonium chloride. The group reagents in this experiment are ammonium chloride, ammonium hydroxide and ammonium hydrogen phosphate. First we are adding solid ammonium chloride to the salt to solution taken in a test tube and make it saturated. Shake it well. Then excess of ammonium hydroxide solution add. Then the group reagent for the analysis of group 6, that is ammonium chloride, ammonium hydroxide and ammonium hydrogen phosphate. So first we already added ammonium chloride and ammonium hydroxide. Now we want to add ammonium hydrogen phosphate. Ammonium hydrogen phosphate. Just observe the change. That is, you can see a white residue is formed. That is, indicates the presence of group 6. The group reagents are ammonium chloride salt solution. To the salt solution we added solid ammonium chloride and ammonium hydroxide and ammonium hydrogen phosphate. Now just observe a white residue that is formed, indicates the presence of group 6. Now we want to analyze this group 6 to check whether this group 6 contains this magnesium. That is, for that we have to do the conformity test for this magnesium. The first test for the magnesium, that is the using Magnuson reagent test. For that we have to take this salt solution in a test tube and add some 2 or 3 drops of Magnuson reagent to the test tube to analyze group 6. Just check it well. Just observe the change. Yes, observe the change. Just shake it well then test tube. Now we got a blue color. This blue color that confirms the presence of magnesium. When you use Magnuson reagent, you will get a blue color if magnesium is present. So we confirm the presence of magnesium using Magnuson reagent. Blue color is obtained. Blue color is obtained. Next, we want to do another confirmative test for this magnesium, that is called the ash test. For that, you will have to take salt solution in a test tube. You can add some more to the salt to this. Take the saturated solution of the salt to get the better results. Take salt. Yes. Make a saturated solution of the salt. make a saturated solution of the salt. For doing the conformity test, that is called the ash test. And to the salt solution, you will have to add concentrated nitric acid. That means 1 or 2, 3 drops of concentrated nitric acid is added to the saturated solution of the salt. Then shake it well, just shake it well. Then you will have to add cobalt nitrate solution. Cobalt nitrate solution to the test tube. Cobalt nitrate is you add this cobalt nitrate solution to the test tube that contains the salt solution plus concentrated nitric acid and cobalt nitrate. Now just shake it well. Shake the contents in the test tube well. Then heat the contents till it boils. So the analysis of group 6, that is for the conformation of magnesium, we will also perform the ash test. We already added to the salt solution concentrated nitric acid and the cobalt nitrate solution. Then boil the contents. Boil the contents in the test tube, and to the boiling solution, just dip a filter paper. Dip the filter paper in the solution and then burn the filter paper to get ash. Here if magnesium is present, you will get a pink ash. So this is called an ash test. This is the second conformity test for magnesium. That is, we analyzed and we got group 6 as cation. Now this group 6 contains magnesium. So we confirm the presence of magnesium using magnesium reagent test. Then the next test is ash test. In the ash test we got pink ash. That indicates the presence of, confirms the presence of magnesium cation. Then you have to color this ash in a dry wash glass and cover it with a funnel for presentation. Just cover it with a funnel. So we analyzed the presence of anions and cations present in the salt. So the given salt, the result is the given salt contains nitrate as anion and magnesium as cation. Thank you, children.